In the lesson 6.4 example, how far from home do you attend college? We're going to do some normal calculations involving p-hat. A polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. And suppose that 35% of all first-year students attend college within 50 miles of home. We want to find the probability that the random sample that we've selected of 1,500 students will give a result within 2 percentage points of this true value. That is to say, somewhere between 33% and 37%. Anything in that range would be within 2 percentage points of the true value. So in this case, p-hat we're going to define as the proportion of students in our sample who attend college within 50 miles of home. And for the sampling distribution of p-hat, we're going to use 1,500 for n because we have 1,500 people in our sample, and p equals 0.35 because 35% of all students are within 50 miles of home when they attend college. The mean of all the different p-hats that we could get is p, which is 0.35. The standard deviation of all the p-hats is the square root of p times 1 minus p over n. And so we substitute in the appropriate numbers here, 0.35, 1 minus 0.35, and 1,500. Take the square root of the whole thing, and we end up with 0.0123. And the shape of the distribution of p-hat is approximately normal. Since n times p is greater than 10, in this case n times p is 525, and n times 1 minus p is also greater than 10. In this case, that number is 975. Both of which are greater than 10, and so we can continue using a normal distribution to find this probability. So these are the numbers that we had from before. We can draw a normal distribution with the mean at 0.35 and standard deviations of 0.0123. So we've marked off 1, 2, and 3 standard deviations in either direction. We want to know what the probability is that we're within 2 percentage points of 0.35. So we'll mark off those boundaries here, somewhere between 0.33 and 0.37. So we're going to find the z-scores at each of those, find the probabilities that we end up to the left of each of them, and do some subtraction. That's our plan. The first z-score is going to be 0.37 minus 0.35 over 0.0123. Gives us a z-score of 1.63, and the probability that z is less than 1.63 is 0.9484. We get this probability from table A. Now this gives us this entire area that we want plus this tail. We don't want this tail, so we'll find the area in this tail and subtract. Over here, this z-score, unsurprisingly, is negative 1.63. I say unsurprising because it's just as far from the mean as 0.37 was, but it's on the other side. So it's going to be a negative z-score, but it's just as far from the mean, so it's negative 1.63. The probability that z is less than negative 1.63 is 0.0516. Again, we got this value from table A. By subtracting, we find that the probability that we end up in this region is 0.9484 minus 0.0516 is 0.8968. So about 90% of the sample proportions will be within 2 percentage points of 0.35. If you'd like to try a problem like this in your book, you can try exercise 9 in this section.